Hello, this is Robert, and in this video I would like to demonstrate the use of a static class member and also the object-oriented design concept of composition. So I have a project set up with two classes, one called name and one called employee, and then this is my main function, and you can see that it's pretty simple. I have a cout statement, and then I create two employee instances, one using the default constructor and one using a constructor that takes 3 arguments. Then I have employee number 2 say her name, and then I have another cout statement right there. So the first cout statement basically tells us how many employees there are. And notice that I'm accessing a static member in this cout statement. I can access static members of a class by using the name of the class and the scope resolution operator right there. Also notice that I don't have to have an instance in order to access the static member of a class. I can access it even when there are 0 instances of the class. When the program starts up, I haven't instantiated any employees, and so that's why I get the output, there are 0 employees. Then I create 2 employees on those lines right there. So then after I've instantiated those 2 employees, I do that same cout statement right here, and now that cout statement says that there are 2 employees. Let's take a look at how we declared the static member. And so here's the employee header file, and we can see that number of employees is declared in the public section, and we just use the keyword static. When we use that keyword static, it means that the number of employees is shared between all instances. So there's only one version of number of employees. Notice that we didn't initialize the value to 0 right here, and the reason why is because this is against the C++ standard. We're not allowed to initialize a static member in line. So what we have to do is we have to initialize this static member in the implementation file. And so I've switched to the implementation file, and you can see that it is initialized to 0 right here on this statement. These are our constructors, and so you can see that I have added 1 to the number of employees for a very simple default constructor, and I've also done the same on this line 21 right here. So the number of employees is shared between all instances of a class. Now let's take a look at how this project is organized. This is the employee header file, and you can see that there are 2 private members of employee. We have an integer, which is a start month, and then we have a name class instance called empName. So we're going to be storing the employee name inside of a member class, and so this is composition. An employee is composed of another class called employee name. If we take a look at the name class, we can see that there are 3 private C strings, then we have some mutators, and then just 1 accessor, the default constructor, and then a constructor that takes 3 arguments. The way that composition in C++ works is that the constructor for the member classes run and complete first before the constructor for the enclosing class completes. So in the main program, I've set a breakpoint right here so that we can see the order of constructors. So I'll start up the program, and when it reaches line 14, it will hit that breakpoint, and so now we're in break mode. If I click step in, I can see that the default constructor for employee is running, And then if I click step in one more time, we'll see that it switches to the constructor for the name class. And that's because we have a name as a member of employee. So the constructor for the name class will complete first, and then the constructor for employee will finish last. So the way it works is that the constructors of all of the member classes run and complete first, and then the outside class constructor will complete. Well, this can create a problem if we would like to run any other constructor besides the default constructor. Remember that the name class has two constructors. We have the constructor that is the default, which takes no arguments, and then the constructor that takes 3 arguments. Well, the way it's set up right now, the only thing we can do is always run the default constructor. We have to do something special if we would like to invoke this constructor that takes 3 arguments. But for now, let's take a look at kind of a workaround for this problem. So if we take a look at the constructor for employee, if we would like to set the name of the employee when we create the employee, basically what we have to do is we have to use the mutators for the class. So basically what we're doing is the constructor for employee that we're using to set the name of the employee basically calls the mutators for each of the variables that we would like to set. There might be a time, though, where we actually do need to select the constructor that we would like to run. So in the next section, I'll show you how to set up an initialization list, and that way you can pass on the arguments from one constructor to the member constructors. So let's modify the constructor that takes 3 arguments for employee so that instead of using these mutators here, let's modify it so that we can use an initialization list to actually run the constructor for the name class so that we can pass on these arguments to that version of the constructor for name. As it stands right now, the default constructor for name will be executed. If we would like to pass on the information to one of the members of the class, what we need is an initialization list. So what we do is in the constructor, in the header for the constructor, we use a colon right there, and then if we want to pass on some information in our initialization list, we just list the members that we would like in the initialization list. So what I can do is I can list employee name right there, and then I can pass on F name, M name, and L name. This will cause the constructor that takes 3 arguments for name to run instead of the default constructor for name. Notice also that I have a simple integer in the header file. I have start month right there. Now that I have an initialization list, if I want to, I can go ahead and list that here in the initialization list as well. So if I want to initialize start month, and let's say that we just assume that they started in July, we can list the other members here. This is an integer and it looks a little strange, but what we can do is we can initialize the integer start month to 7 in our initialization list right here. The other way we could handle this is we could just place it inside of the constructor like normal as well. So we could say start month equals 7. So now that we have an initialization list, we could put start month in the initialization list if we wanted to, or we can just list it in the constructor like normal. I have moved the breakpoint. Well, let's set up the breakpoint on line 15 now so that we can see which constructor will be activated for the employee name. So I'm going to start the program and we'll go into break mode when it reaches line 15. So then I'll click Step Into, and then we can see that the breakpoint is now on the initialization list. And so if I step into that one more time, we can see now that the proper constructor for the name member, emp name, was called. And so that's how we can pick and choose which constructor we would like to run for each member class by using this initialization list. So that does it for composition.